So as we move into grade 5 with fractions, we're going to again build off of what we learned in grade 4, grade 3, grade 2, grade 1. And in this conversation, we want to use both visual models and equations or numbers. We want to use both representations because we want to develop a very strong conceptual understanding. So what might that look like if we're adding and subtracting fractions with different denominators? And I'm going to show a couple different ways we can kind of process this. So I'm going to give an example here. And we're going to talk about here, I've got 2/3 plus 3/4. So conceptually, I can start here and say, okay, 2/3 plus 3/4. So here's 2/3, and I want to add 3/4 looking at this too. So I want to kind of see here. So when I'm doing this, I've got 2/3 and I literally have 3/4, and I want to add those together. And the challenging part with that is when I'm looking at this idea, when I'm looking at 2/3 plus 3/4 and processing through here, I can't say that that's 5 of anything because I'm comparing two different things and understand. So here's thirds and here's fourths. So it's not 5/3, it's not 5/4, it's not 5/7. That doesn't really make a whole lot of sense. So what I might need to do is I might need to find that common denominator. What's something I can break thirds up into, the same thing I can break fourths up into? And we're going to talk about some different ways we can process this. But one way I can do that is I can think about, well, I know that thirds can be broken up into 12ths if I divide those into 4 equal parts. And I'll show another way we can do this in just a minute, but I can kind of look into here. I know that I can break this up into here. So when I look at this, I can begin to say, okay, so 1/3 is 4/12. This 1/3 is 4/12. This 1/4 is 3/12. This 1/4 is 3/12. This 1/4 is 3/12. So I can see that the 12ths aligns perfectly with each of these original fractions. So 1/3, really 2/3 plus 3/4 equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 equals 17/12. So I can come into here and say, okay, that's going to be 17/12. But let's say I wanted to kind of represent that in another way. What are other ways we can kind of make sense of this? So I'm going to clear this out. Is there a common denominator I can find? And one of the ways we're looking at the common denominator, this is a whole unit and most programs we're looking at, so I'm going very quickly here. I can begin to think this conceptually as I'm 2/3 is equal to how many 12ths, looking at that. So I know that 2/3, if I do, let's see, times 4 and times 4, I know that 2/3 equals 8/12. And then I know over here, let's see, just to kind of keep that going, so that's going to be like a little, I'm going to kind of keep this information right there. I know that's there. I'm going to come over here, just another way. I'm not saying this is the best way to represent it, just kind of processing through here. And I know that 3/4, if I come into here, well, okay, if I'm trying to change that to 12ths, because I've learned about common denominators, that's something I can do. I can say times 3 times 3. Again, this is a whole long unit. So then I've got 3 times 3 is 9. I've got 4 times 3 is 12. So I can say, okay, so that's going to be, all right, what I'm looking at here. So now I really have, when I come down to here, this all equals really 2/3. This really could be written as 8/12. We've been building that idea of equivalent fractions. We've been building that back in 4th grade. We built that back in 3rd grade, the idea of equivalent fractions, very conceptually. We just kind of showed it over here. So 8/12 is going to be, now we're going to add that to 9/12. And we're going to say 8/12 plus 9/12 is 17/12. That's another way I could do it. And I suspect many other people have other ways we can do this too. But the idea is connecting that back to original strategies, original conceptual ideas that we have. Now, for all this to work out really well, it's very important that students understand and that teachers understand that students are coming to you with information about, hey, 2/3, how is 2/3 the same as 8/12? So I can really divide this up, looking into here. This can be really, really helpful as we're beginning to think about this. I divided each of the original thirds up into 4 parts. When I divided each of these thirds into 4 parts, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's really important that if I go in here, I'm going to shade this in. Good. I can come in and I can say, hey, this is 2/3, and 2/3 is the same amount as 8/12 is. And that's going to be something, again, we've been building that all the way back since, really, this conceptually was really being built since 3rd grade. So if you are a 4th grade teacher, knowing that they're going to be getting here to 5th grade, knowing they're going to need this, make sure we spend plenty of time on the conceptual idea of what it means to be equivalent fractions. We're going to really build on that when we get to 5th grade looking at some of these aspects.